Today we want to look at addition and subtraction of radicals. A couple things you need to remember to be able to do addition and subtraction. The first thing, like multiplication, our index must be the same for both radicals. The other thing, which is different than multiplication, is that the radicands must also be the same. This was not the case with multiplication. Remember, multiplication, you can multiply the two radicands together to get a different radicand. In this case, our radicands and our indices must be the same. And the final thing what we're going to see is that the index and the radicand will not change. Because of addition or subtraction. Now we will be able to see that we can simplify some of our radicands, in which case we'll want to go ahead and do so. So let's go ahead and look at our first example. In example 1, let's take the square root of 28 and add to it 4 square roots of 63. And maybe, for good measure, let's subtract off the square root of 7. So here we have the addition of 2 radicals and the subtraction of 1 radical. Notice our index is the same for each of them, but our radicands are not the same. But if we remember the square root of 28, we can reduce that by taking our perfect square out, since we're looking at the square root, as our index indicates, that it's a 2. So we have 4 times 7. Square root of 4 will come out and become 2 radical 7. The square root of 63 we can simplify into 4 square roots of 9 times 7. Square root of 9 is 3, so we get plus 12 radical 7. Radical 7 does not simplify, so we're going to simply bring it down as minus the square root of 7. Now in order to add or subtract, what we're going to do is make sure, again, the indices are the same, and now our radicands are the same. So we're going to simply add or subtract those outside numbers. Remember, if there's not a number outside of a radical, it's going to be 1. We can say this is 1 times the square root of 7. 12 times the square root of 7. Here, 2 times the square root of 7. So now radicals we can think of just like variables. So we're going to add the numbers or subtract the numbers on the outsides, or we used to call them coefficients to our variables. So 2 plus 12 is 14 minus 1 gives us 13, and remember that radical is going to stay the same, radical 7. And there's our final answer, 13 radical 7. Now let's go ahead and look at example 2. Example 2, let's go ahead and change that index. So let's take 5 third roots of x minus 3 third roots of x. Notice here our indices are the same as 3, and our radicand is the same. So we can go ahead and subtract these. 5 minus 3 gives us 2. Our index is going to stay 3, and our radicand is going to stay x. We cannot simplify the third root of x, so there's our answer. In example 3, let's look at 2 third roots of x minus 2 third roots of 5. In this case, we have the same index, 3, but the radicand in this case is not the same. We have an x and we have a 5. We cannot simplify the third root of x, nor can we simplify the third root of 5. So this is our answer. We cannot simplify it any further. Now let's go ahead and look at a little more complicated example. in example 4. Let's take 6 third roots of 54 plus 4 third roots of 24 and add to that 5 third roots of 128. Notice my indices are again the same. They're all 3, but my radicans are different. So what I need to do is go ahead and simplify these radicans if possible. Here I'm looking for the third root that goes into 54. I know that 27 is a perfect cube, and 27 times 2 is 54. Here I have 4 third roots. In 24, I know I have 8 times 3, 8 being my perfect third. And I have the last one, 5 third roots. In 128, 64 is my perfect third root. So I can go ahead and take the third root of 27 out of my first radical. Third root of 27 is 3. Remember, it multiplies to the number outside. So I end up with 18 third roots of 2. The third root of 8 in the second radical comes out as 2. So 2 times the 4 that's out there gives me 8 third roots of 3. The third root of 64 in my third radical is 4. 4 times the 5 gives me 20 third roots of 2. Now if I look at this, I have the same index again, but still I have 2 different radicans. I have 2, 3, and then a 2. So the only ones that I can combine are the last one and the first one. So to combine those, I end up with 38. Remember, 18 times 20, I add the outside numbers. I end up with third root of 2. My index and my radican do not change. And then to that, I'm going to add 8 third roots of 3. Since my radicans are not the same, I cannot combine that any farther, and I'm finished. So to recap, to add and subtract radicals, the index must be the same for both of our radicals. Our radican must be the same, and the index and the radican will not change because of the addition or subtraction property. So we simplify all of our radicals to begin with. Once our radicans are the same and the index is the same, we can go ahead and add or subtract the numbers on the outside of the radical. And my radican, and my index will stay the same.